In the finance field, stock market forecasting is very important in the planning of business activities. So stock market has attracted researchers to try to predict its next moves. This research is focused on using news headlines to predict the change in stock prices. So we are dealing with unstructured text data. We are using New York Times articles over the span of 20 years. Then sentiment analysis of these news headlines is used in machine learning models to understand their effect and predict stock indices. We collected news articles from New York Times Archive API over the span of 20 years. Afterwards, we removed categories of articles which were irrelevant to stock market, and out of the 66 million articles, approximately 719,000 articles are filtered out and kept. We use Dow Jones Industrial Average, DJIA, and Russell Stock indices collected from Yahoo Finance website. Composite indices such as DJIA reflect the overall change in stock market. We concatenated all the article headlines for a single day and merged them with appropriate date and stock prices. For the days that there are no stock prices, we use the interpolation method from Panos to fill in the missing values. In total, we have 7,300 data points, and average length of the titles is 6.61 words. We did this project by running Jupyter Notebook on our personal commodity laptops. The evaluation metrics used here are RMSE, MAE, R2, and bias. For clustering approaches, we use accuracy and F1 scores. In this baseline, we have used Vader Sentiment Analyzer, which is trained using social media and news data, and gives a positive, negative, neutral, and compound score for a string. One interesting thing we found out is that the compound sentiment is quite negative, even though the market index is growing in our period. Output of sentiment analysis is then fed to machine learning models to predict DJIA. Since stock market data is of the form of time series, we use the validation technique called decay-fold sequential cross-validation, or KSCV. In this method, we train on all days up to a specific day and test for the next days. Since the prices of the stock fluctuate a lot, we have used the smoothing technique to get smooth curves. On the right are the results of various models for year 2000 using 12 KSCV. In general, 12 KSCV worked better than the lower folds, but all our models performed poorly. This poor performance was also predictable when looking at the correlation between the sentiment scores and stock prices. In this baseline, we are using bag of words that we are all familiar with to predict the Russell Stock Index. First, we count all the vocabularies and then calculate the frequency of the words, and after that, we sort the words to get the top 2,000 most frequently used words. Then we construct the bag of words model. Because of our large number of features, it makes sense to use ElasticNet. One thing to mention is that we decided on using end-day lag sentiment score, which allows us to compare today's article headlines to stock returns of end days later. Here we updated the Vader lexicon with words and sentiments from other sources and ran the same machine learning models. Again, the 12 KSCV worked better. But the modified lexicon only performed better in some cases. In this modification, we used Russell Stock Index instead of DJIA. We also started using stock return instead of stock price. In addition, we decided on using end-day lag sentiment score. Also here, we are using ElasticNet for our model. Here we are comparing the modified version of the first baseline with the results of the original second baseline. As we can see, first baseline is better in terms of MAE and RMSE, but the R-squared is very small. In this experiment, we decided to use classification for a better performance. We labeled returns more than 0 as one class and returns less than 0 as another class. Here we decided to use LDA to do this classification, and here we are doing random forest. In another experiment, we decided to allow a margin of error, so we labeled returns more than 1% as class 1, labels less than -1% as another class, and everything in between as a third class. And then we used LDA to do this classification, and we also used random forest to do it, and the results were almost similar. For the baseline 2 modification, we used PCA to deal with the dimensionality problems, and we can see that RMSE was 1% lower. In this modification, we combined ElasticNet with decision tree regressor, and we can see that both MAE and RMSE dropped. We use two kinds of methods, with label and without label. We combine linear models with nonlinear models to get better results. We use PCA for dimensionality reduction. We use various number of lag days to find the optimum lag day. We experimented with modifying the lexicon of Vader. We have used both regression and classification methods. So combining linear and nonlinear models showed an improvement. Classification methods also showed a big improvement. Even though the small modification to lexicon didn't really show a good result, it's definitely a starting point. And comparing the various number of lag days also was beneficial to us. In the future, we could try training deep learning models on our data. We could also try classifying news and articles based on a specific stock or a specific business. We could also train our sentiment analyzer based on only news headlines, for example, specifically on New York Times headlines. We could also take into consideration the stock fluctuation patterns in addition to our sentiment analyzer. There's also room to explore the effect of news on the stock in a second or a millisecond time frame.